Dear students, good evening. The day before yesterday, we discussed about measurement of velocity, right? Measurement of velocity, right? There we studied about electromagnetic type, revolution counter type, tachometers, that will be capacitive type, breakup type, right? And tacho generators, AC/DC types, and stroboscope. Right? So these are about your velocity measurement half of your third chapter, and remaining half nothing but measurement of acceleration. So what is acceleration? What is acceleration? Acceleration, acceleration nothing but rate of change of velocity. Rate of change of velocity. So what is vibration? Vibration nothing but sinusoidal displacement. Sinusoidal displacement. Nothing but vibration. Generally, the acceleration vibrations are generally the same meaning it will come, vibration and acceleration. Okay. See, we have to represent like this: acceleration nothing but rate of change of velocity. Rate of change of velocity. So if you use this rate of change of acceleration, it will nothing but jerk, nothing but shock or jerk, shock or jerk. Okay, so you have the same concept in the third year first semester, measurement of acceleration, right? The instrument which is used for measuring the acceleration nothing but accelerometers. Accelerometer. Uh, so there's a difference between vibration and acceleration. The meters, vibrometer and accelerometer. So here we are mainly focusing on acceleration measurement. Acceleration measurement. So the output of acceleration is always function of accelerometer is a transducer whose output is function of acceleration, right? It provides a direct measure of acceleration. Displacement and velocity can be determined by integrating the output of accelerometers, right? So the generally acceleration comes under a primary transducer. So here, how this vibration is going to measure is a small picture is provided here, small picture for measuring vibration. So if this body is vibrating or having any rotations, so by applying some stroboscopic lights, you can easily measure it. That's what yesterday class we know. And sometimes the cantilever type, the vibrations can also be known with the help of cantilever or reed type vibrometer, reed type. Right? So if any vibrations are given to this, so this cantilever it will move, it will deflect. Based upon this deflection, there is a scale. On the scale, there is marking on the scale. That marking value will give the vibration value. Right? That's about a simple vibration measurement. But actually, you are not. There is no separate word in the vibration in the syllabus. He's mainly focusing on the acceleration. So acceleration, uh, acceleration, nothing but rate of change of velocities. So we have different simple instruments available. Acceleration level indicator, one shot type acceleration level indicator, like this. But actually, as per the syllabus, we have a measurement of acceleration using piezoelectric type. Piezoelectric type. So, what is piezoelectric transducer? First of all, piezoelectric transducer is one in which if you apply any mechanical force or any mechanical input, or pressure, so it will convert into suitable voltage. Suitable voltage. So, how do you realize that piezoelectric transistor? There are two plates. There are two plates, plate 1 and plate 2. In between there is a crystal. There is a piezoelectric crystal, a special type of crystal. It is made with, it's a natural crystal made with, maybe it may be Rochelle salt or quartz. Of course, in the industry we have to use man-made crystals also, man-made crystals. Okay, but there are natural crystals available, Rochelle salt uh, and quartz, right? So with these two crystals, you can get the applications like we simply converting any stress, any strain, or mechanical force, mechanical pressure into electrical signal. Electrical signal. So the electrical signal, electrical voltage is always proportional to the input what we apply. So this is the basic principle of your piezoelectric type transistor. But how this device is able to use for measuring acceleration? Very simple. So the same structure you can experience with accelerations where the accelerations occur. That is exposed to your accelerometer, which is designed with piezoelectric material. What happens? Because of that acceleration, the body will have some moments. The accelerometer, piezoelectric accelerometer having some motions, right? So because of that motion, what happens? There is a change in the, yeah, there is a, so because of this acceleration, so what is this? This is a plate 1, this is a plate 2. These two are connected to output voltage. In between these two, you have to provide some crystal. So what are these plates? These two plates so-called electrodes. Electrodes. And on this plate, we are placing a fixed mass. Fixed mass. The total body is enclosed in a cap. In a cap. Supportingly with base. With base. So to this structure, if you exert with acceleration, what happens? There is a movement in the mass. Actually, here we have to provide some spring. Here we are not showing a spring. So above this mass, there should be some uh, circular spring. Circular spring. So what is the importance of the circular spring? If a total body experiences any accelerations, rate of change of velocities, what happens? The spring may get some force. That force will apply on the mass. So because of that mass, it will press the crystal, through the plate. So when the crystal is pressed on the crystal surface, there is a charge carrier, moment of the charge carrier on the surface. On the surface, there is a moment of the charge. So when the charge carriers are moving, moment of the carrier is nothing but voltage. So Q, the charge, otherwise voltage can be right Q by C. Q by C. Voltage, output voltage can be right Q by C, where Q nothing but charge, C nothing but capacitance existed between plate 1 and plate 2. Plate 1 and plate. So if a mechanical force is applied, or any pressure is applied, or any acceleration is applied, what happens? Because of the spring, it experiences a force that will present on the crystal. So when the crystal experiences any pressure or force, there is a charge distribution, moment of the charge on the surface. So because of the charge and the capacity available, there exists some voltage. Voltage can be right Q by C. So that voltage is proportional to your acceleration. Your acceleration. Because how to write Q? Q nothing but Q nothing but charge nothing but force into Q. Q. Q depends on, the charge depends on force. How do I have force? Force equals to F into F equal to MA. M is fixed. Here M is fixed. So your charge proportional to acceleration. Charge is proportional to acceleration. That means your voltage is proportional to acceleration. So if acceleration is more, your voltage is more. So this is called piezoelectric type accelerometer. Next, see this relation F equal to MA as per Newton's law. Okay. There are some advantages with this: brightness, high output impedance, and high frequency, high sensitivity. I mean, ability to measure accelerations from a fraction of g to thousands of g, and very small inside. These are some advantages. Maybe some disadvantages. Variations in temperature is a temperature problem, and hysteresis problem. Hysteresis problem. So it is response is very poor when the frequency is less than 10 Hz. Okay. So next one is seismic accelerometer. Seismic means here we are using a crystal. In this diagram we are using crystal. So in the place of crystal, if you if you use any dashpot and spring, and here if you use any position transducer, thus diagram nothing but seismic transducer. Seismic transducer. Yes, yeah. Here there is no crystal. There is no crystal. There is a damper and spring and a displacement transducer, nothing but position transducer. Also called position transducer. So it's a seismic transducer. So if any vibrations occur, vibrations means accelerations, sinusoidal displacement, nothing but vibrations occur. It is completely inside the home, inside the housing. So if you apply x1 as vibration or acceleration, it experience x2. It experience x2. Because of this, damper and spring are moving. They are moved. So because of spring, it provides some dynamic damping. So when they are moving, there is a displacement transducer. It will give some pointed value. It provides some pointed value. That pointed value, nothing but amount of the acceleration what we apply. It is nothing but displacement transducer, also called seismic transducer. It is also called, potentiometric type. Remember, in the syllabus he is mentioning potentiometric, seismic, both are same. Understand? In the syllabus he is mentioning potentiometric, but here there is a word seismic. Seismic and potentiometric same. So displacement here means here we have to provide some potentiometer with wiper. So potentiometer with wiper. So when any accelerations occur, the wiper is going to move. Because of the wiper movement, there is output voltage. That voltage is proportional to your acceleration applied. Okay. This is about the theory regarding this. All this. You can also do this for cantilever purpose. Cantilever. See, a cantilever means is a cantilever. To this, at one end we are fixing the mass. At here we are providing some strain gauge. We are providing. This is completely on the housing. So, if this total body experience any accelerations, so the cantilever will move like this. Up and down like this. So when the cantilever move like this, the strain gauge the resistivity of the strain gauge is going to change. First of all, what happens? Resistivity changes. The resistivity of the strain gauge changes. Then what happens? R equals to capital R equals to rho L by A. L A fix it. Rho L by A. L by A fix it. So R proportional to rho. So what happens? If resistivity changes, the resistance changes because R proportional to rho. If resistivity changes, R is going to change. Resistance is changed. So that change in resistance can be measured with the distance bridge. Measured with the distance bridge. So it will give some voltage. That voltage is proportional to your acceleration applied. So this is a cantilever type. Cantilever type. And LVDT type. So what is the reluctance type? The reluctance type nothing but LVDT type. So LVDT accelerometer also be called reluctance type. In the syllabus is mentioning reluctance type. So what is LVDT? LVDT is nothing but, imagine once again the conception. There is one primary coil and two secondary coils. In between primary and secondary coils, there is a core, soft iron core. Soft iron core. So the total is available in the complete housing. Complete housing. For this, if you apply any acceleration to the core is going to move. When the core is going to move, what happens? It induces an EMF in the secondary coils. And EMF is induced in the secondary coils because of change in reluctance in the coil. Change in reluctance of the coil. So because of that electrical parameters changes, an EMF is induced. That EMF is proportional to your acceleration present. Your acceleration present. This is about LVC accelerometer. Yeah, see. So we are showing the same LVDT like this. LVDT like this. So the two plates, yeah, plate 1, plate 2, and here we have the reed. Reed means it provides some damping. Provides some damping. So because of this, if any, accelerations occur, so the plate positions are going to change. I mean, um, I mean, when you apply any acceleration, the core is going to move. It will use some EMF. That EMF proportional to your what is called acceleration. But here this diagram shows that capacitance type, capacitance accelerometer. In the capacitance accelerometer, see what is parallel plate capacitor? Parallel plate capacitor, nothing but there is a plate 1, plate 2, in between a medium. Medium means here, medium may be sometimes medium may be a dielectric medium. Dielectric medium. Otherwise, it can provide some distance between two plates. Distance between two plates. What happens? See, the plate, this plate is fixed. This plate is movable. This plate connected to a reed. A reed means a mechanical connection which provides a damping. It provides a damping. Okay? This is a plate 1, plate 2. Initially, before applying acceleration, the two plates are having some distance, initial distance. Then what happens now? If you apply any unknown acceleration, the movable plate will come towards down or towards up because of the reeds. Reeds will provide some damping. Because of this damping, this plate towards the stationary plate or far from stationary plate. Then what happens? Distance is going to change. When distance changes, the capacitance changes. The change in capacitance is measured with the shearing bridge. Shearing bridges. That provides a voltage. That voltage is proportional to your unknown acceleration. It is called a passive accelerometer. Okay. So it is inductance type accelerometer. Induction type. Induction type means, so because of the voltage excitation, we are fixing some voltage to this coil. So it flows some, it will it will energize. It will energize, and when you apply any acceleration, so because of this magnet will move. Magnet will move. When this is moved, so it will have some rod. It will displace. So when it will displace. So like this, it will displace. What happens? It creates some voltage in the coil. Provides some voltage in the coil. So what happens? If you apply any vibrations or accelerations, it's a coil. This rod magnet will move like this. It will experience some acceleration. So when the magnet is going to move inside this coil, what happens? It uses some, the electrical parameters are going to be changed. Flux, reluctance, all are changes. When all are changes, it creates some voltage. Creates some voltage. That is proportional to your acceleration. See, solve. So it is works on different I mean methods we can apply for measuring acceleration. Okay, I think these are all available in the syllabus. Okay, uh, um, then now I am going to stop here. If you have any doubts,